Hello, I'm Ms. Kennedy, and today I'd like to share some of my rock collection with you. I'm not a geologist, I'm not a scientist who studies rocks, I'm just a person who thinks rocks are interesting, and I like to learn about them. And I have a book here. This is a great book for learning about the rocks that are around you. National Audubon Society First Field Guide to Rocks and Minerals. And I use this all the time. So rocks are basically made out of minerals and elements. So what's a mineral? Well, there's a mineral that we use all the time. And let me show it to you. This is salt. And you can see that a lot of the grains of salt have some flat sides to them. And some of them are very dark pink, some are very pale. This is salt. Another element that we use a lot is this yellow one. Do you see those crystals on it? Do you see how they shine? They sparkle. And then the other side of the rock doesn't look that interesting, but the yellow part, it's a very nice bright yellow. And this rock actually has a smell to it. It smells a little bit like hard-boiled eggs. This is sulfur, a yellow mineral that we use in many different ways. And this is its natural form. So those are some minerals. And minerals are made up of crystals. This is a piece of quartz, and you can certainly see the flat edges to it. This wasn't carved this way. This is how it grew, how it formed. And here is another piece of quartz. I don't know if you can see the rainbow that forms inside of it. It's kind of cracked it has a crack there, so it makes sort of a rainbow shape, a rainbow in there. Okay, so we've looked at some minerals and we've looked at some quartz crystals. There are different ways that rocks get formed, and one way is by sediment in rocks and rivers getting pressed down over thousands and thousands of years, and that pressure solidifies that mud and muck into rock. So these are two examples of sedimentary rock. And because a lot of sedimentary rock comes from mud, do you think that this is where we would find fossils? Indeed we would. There's a fossil right there. See if I can find it. Oh, there's another one right there. And do you see the layers in this rock? You can really see those layers. And there's another little creature that's been fossilized in there. And this is a different kind of sedimentary rock. There is a fossil there. There's another fossil there. And this sedimentary rock feels very rough. This is sandstone. It is made up of sand that has been pressed down over thousands and thousands of years until all of that pressure turned it into rock. So those are two good examples of sedimentary rock. So this might well be a different kind of rock, but it began as a sedimentary rock. Do you see how it looks like mud? You can see where things were made dents in the mud when it was still mud. And here is another example. And I want to show you one of my favorites. So this is a rock from where I grew up on Long Island, New York. And this is a sedimentary rock that we called paintstone. And another thing about sedimentary rocks is they're usually softer than other kinds of rocks. So this sedimentary rock if I wet my finger and rub on the rock, a little bit of the color comes off because this rock is so soft. So this was once mud. Okay, so quick look at some sedimentary rocks. And volcanoes. Volcanoes produce all sorts of rocks, and the rocks that volcanoes produce are called igneous rocks. And igneous rocks are broken into two basic categories. So this is a piece of granite. Do you see how it has all those small pieces on it? And can you hear how rough it is when I rub my finger over it? And I can see some things sparkle in it when I hold it up to the light and move it. So this is granite. It's very heavy too. So this is an igneous rock. It was formed by molten lava cooling inside of the volcano. It cooled slowly inside of the volcano. This is also igneous rock. Do you see how shiny and glass-like it is? This is called obsidian. Obsidian cools very quickly outside of the volcano. And with obsidian, when you're handling it, you have to be careful because the edges can be sharp, just like glass. In fact, obsidian was often used to make arrowheads because it could be broken into nice arrow shapes, and they were very sharp. So I have an example of an arrowhead that has been carved out of stone. Okay, so these are two examples of igneous rocks, rocks that are formed by volcanic activity. And then there's a third category of rock, and that is called metamorphic. So metamorphic, that sounds kind of like metamorphosis, which is what cocoons do, caterpillars do, and they turn into cocoons and then into butterflies. So these are rocks that change. So here's a good example. This is a sedimentary rock called slate. And one way of knowing that it's a sedimentary rock is we can see those layers. See the layers? And they look like you could pull them apart, but you can't. This is a very strong rock. Slate has been used for roof tiles, for building, and also for chalkboards in classrooms. My dad worked in a very, very old school when I was a little girl, and his blackboards were made out of slate. So this is slate, a sedimentary rock. This is shale. Shale is a metamorphic rock. Shale is slate that has been under a great deal of pressure, heat, for thousands and thousands of years, and all of those layers get squished together very tightly. So you can't see them anymore. So even though this rock is bigger, this rock is a little bit heavier. So do you see the difference in that? So a sedimentary rock changed over thousands and thousands of years with pressure and heat, changes, metamorphosizes into a different kind of rock. Shale. And then there are these wonderful things called geodes. So what are geodes? Geodes are rocks that I believe they're generally formed through volcanic activity. And people who search for geodes know what to look for on the outside so that when they take it home and they cut it open, they'll find something on the inside. They don't always find something pretty. So this is a geode that somebody cut open and they went, you know what? That didn't turn out as pretty as I like. This kind of a geode is called a thunder egg. And this is the state rock of Oregon. So this is one that's been cut. It hasn't been polished. This one has been polished. And there's something that you might know that comes out of geodes, that's formed in geodes. So there is the outside of the rock, and there's the inside. So this is amethyst. This is an amethyst, a part of an amethyst geode. And amethyst is used to make jewelry. It is the birthstone of people born in the month of February. So amethyst comes from a geode. Here's a big piece of amethyst that's been polished. But even unpolished, do you see how shiny those surfaces are? So that is amethyst. I have another rock here that's used a lot for jewelry. And you can see the lines in it, the layers. And it's not very shiny here, but then often it gets polished. So this is a piece of tiger's eye or cat's eye. And here is a piece of tiger's eye that has been polished, tumbled and polished. And we think of cat's eye or tiger's eye as always being this amber brown color. Oh, here's another nice piece. It can also come in blue and red. The red is very, very rare. So what a lot of people do, instead of getting real red tiger's eye, they dye it. So this is a piece of dyed rock. It was colored. It used to be one of these colors. It was colored to look like red tiger's eye. And this is blue tiger's eye. You can't see the lines very well on this. But I think the unpolished is pretty interesting. So that's tiger's eye. There we go. And let's, oh, I like this. So these are crystals. This is how they form. These were not cut that way. And these are 8-sided crystals. I've dropped this one a few times. If I drop it again, I think it will break. So these are 8-sided crystals, and this is how they form. This is also the same kind of rock. The crystals have just formed in a different way. So this is fluorite. Not fluoride, but fluorite. And this is where we get fluoride that we use to protect our teeth from cavities and decay. And fluorite can come in a variety of colors. It can come in greens and purples and almost transparent. I just think it's interesting that the crystals grow that way. Okay, let's see. So I have two stones here that look very similar. But I'm going to use a test to see if I can figure out what they are. So I'm going to need to use a magazine here. So I have a magazine, And I'm going to see what happens when I put these two stones on top of the image on the magazine. And I can see the image through this one. I can see it more clearly through this one. Let me see if I can hold that up for you. Well, maybe you can see it. So when I look through this one, the image underneath it has doubled. It's like there's two of them. And if I turn it on this side, I can still see through it. So if I turn it, I can still see through it. Any way I turn it, I can see through it, and I get a sort of double image effect. This one, I can see through it when I hold it this way, but it's not a double image. It's actually pretty clear. But when I hold it this way, I can't see anything. Just white. When I hold it that way, I can see through it. That's interesting. So what I did was I looked up in my book to see what looks like calcite. I know that this is optical calcite. I know that it's optical calcite because of the way I can see through it. Remember, I turned it on every edge. I could see through it on every edge. And what I saw was a double image. That tells me that this is optical calcite. Now this one, remember, I can't see through it. On this side, I can see through, and on this side, I can see through, but these edges, I can't. This is actually a piece of gypsum, something that we certainly use to make things like gypsum board. So they look very much alike. I had to think about what I observed and then take my ideas to a book and do some research. Okay, so optical calcite and gypsum. This is a mineral that you've probably seen quite a bit. What does that look like to you? And it's pretty heavy for how small the pieces are. This is copper. What pennies are made out of. And we use copper for so many things. And people have been using copper for thousands and thousands and thousands of years. Oh, I've got one here. So look at this piece of rock. See how shiny it is? And the color of it? And it's actually pretty heavy for as tiny as it is. Oops. You can hear how heavy it is. So what do you think this is? Silver? That's a good guess. That's a good hypothesis. Or fool's gold? Is it pyrite? It is not. By looking at the shape of the crystals in the rock, and also checking to see if there was any magnetism to it, because hematite looks very much like this, so I can see if it's magnetic. Nope. I'm getting maybe a little bit, not much magnetism. So it's not hematite, it is not magnetite, it's not a ferrous rock. This is called galena. And this is a rock that I do have to be careful about. I don't want to touch my face after handling it. Galena has a lot of lead in it. That's why it's so heavy for as small as it is, because it has lead in it. So this is a piece of quartz with bands of black running through it. Like somebody dropped thread in there. I believe the threads of rock are tourmaline. I know that when quartz is like this, it's called tourmalated quartz. Let me see what else I have for you here. Oh, okay. Let's talk about fossils. So when I was a little girl, I visited family in Kansas, and I saw these really cool rocks. And I saved a couple of them. And I never could figure out what they were. They kind of looked to me like maybe they were fossilized antlers. See why I might have thought it was a fossilized antler? So a few years back, I went to a rock and mineral show in Stockton, and I brought this rock with me, and I hoped that I could find somebody who could identify it for me. And the person I showed it to said, "This is a fossil, but it's not from an animal. It's from a tree. It's the fossil of a tree branch." And you can almost see the rings in there. So I think that's a pretty interesting fossil that I have. I like that one. And let's see, I've got some more fossils here that I do like. So if you've ever seen a sand dollar, these are relatives to the sand dollar. I've heard them called sand biscuits or sea biscuits. Do you see how they have that design like on a sand dollar right there? So these are fossilized sea biscuits. Fossilized sea animals. And there's another fossil here. And then this fossil of ferns. And I have another fossil for you. Okay, what do you think this is? So there's actually two pieces there. They're both different in color. They have sort of a similar texture. These are two pieces of petrified wood. So this is wood that has fossilized. And if you would like to see a piece of petrified wood up close, the Lodi Lake actually has a great big piece of petrified wood between the entrance where you pay for your parking and the playground. It looks sort of like a bench lying on the ground, and that's a big piece of petrified wood. Let's see what else I have for you. Oh, I like this. So I'm going to go back to talking about sedimentary rocks. So again, this is a piece of sedimentary rock. I believe it is sandstone. See how I can flake off the sand? So it's pretty soft. I have a theory about what kind of rock this is. I'm not sure, I'm not a geologist, but based on what I've learned about sedimentary rocks and metamorphic rocks, I think that this is a sedimentary rock that has been metamorphosized. I can see the layers here, and I can see layers there, but I can't see any kind of the crystal formation. It's like it's all been pressed together, and this is very smooth. So I'm pretty sure that this is a metamorphic rock, a rock that has metamorphosized from a sedimentary rock. This is a rock called malachite. It's naturally this very bright green. And it does get polished and cut and used for jewelry. Let me grab another kind of stone that is used for jewelry. This is rhodonite. Do you see the pink in it? And it has a lot of shine to it. The crystals in it really reflect light. So this, oh, I'm sorry, I said it, yeah, yes, this is the rhodolite. Then this is tourmaline, which is also used. And neither one of these pieces are the quality that would be used for jewelry, but they are pretty. And this is some topaz. I'm thinking that perhaps topaz comes from a geode like amethyst by looking at the outside of it. I'm not sure, though. I would have to look that up. And this is mica. Mica is transparent. And the thing about mica is it can break off into thin sheets. And sometimes you can do that with your fingernail. So do you see how it broke off very cleanly? See how smoothly that broke off? So based on what I know about mica, that it cleaves, that it breaks off smoothly into long straight lines, and how flaky it is. This is mica. Again, it looks very much like glass, doesn't it? Okay, I'm going to show you one more thing. Where are you, baby? I know you're here somewhere. There we are. So I showed you some amethyst, which is the birthstone for February. This is garnet. And I believe it's in what's called garnet schist, a rock called schist that is holding those garnets there. Garnet is the birthstone for the month of January. So if you were born in January, that is your birthstone. Oh, I almost didn't show you this, and I want to show you this. This is another one of my favorite fossils. So if this is a fossil, what kind of stone must it be? It must be sedimentary. This is a piece of coal. Coal has been used for centuries for fuel. And this is actually a rock with some silver in it. Can you see some of that shiny spots in it? This is a rock that has some silver in it. So remember the galena that we looked at? The leadstone? The galena looks more silvery than the silver rock, doesn't it? Oh, here we go. I'm mixing up my rocks. And this is a rock that has some emeralds in it. Do you see the emeralds? So I just thought I would share some of my rocks with you and maybe inspire you to look at the rocks that are around where you live, the rocks that you can see. Thank you for sharing some time with me today. Have some fun going out rock hunting. Be well.